The other commands that are in mod sprites, I've lots of comments. I put the ball x, ball y, speed x, speed y in here. They should really go in a separate module called init vars. Then we've got background sprite as long, ball sprite as long, ball sprite mask as long, my back buffer as long, and my buffer BMP as long. And these are all longs, which is a long number, and it's the memory location for all these different things. So the load up sprites sets up my back buffer, sets up my buffer BMP, create compatible bitmap, select object my back buffer, my buffer BMP, and then bitblt blank VB whiteness, which actually is black, to the my back buffer, and then we load up the sprites. Background sprite equals load graphic DC at path and quotes /graphics /bolide.jpg, which is the background, and then loads up ball sprite equals load graphic DC brackets app.path and quotes /graphics /ball1.gif. Ball sprite mask equals load graphic DC /app.path and quotes /graphics /ball1 mask.gif. So let's explain this. Background sprite, load the graphic from, and then we use app.path to see whereabouts you are. This is a relative path to the starting application. So look in where you started and look in the subdirectory called graphics for bolide1.jpg, and this will load the graphic up for the background sprite. And the ball sprite, we're going to use the GIF ones, and that loads them up. Load graphic DC is also defined, and it takes the string that we've given there and finds it and loads the picture up and sticks it into memory. And at the end, when we're finished, we need to delete all the sprites to make sure that there's no memory leak. If you don't do this bit, every time you use it, you'll gradually run out of system memory and system memory, as it doesn't free up the memory. So you've got to free up the memory once you've used it. And that is mod sprites. So this is starting to get towards a proper game engine. And in the next lesson, I'll show how to use this with a slight modification to start using DirectDraw and DirectX 7. So let's just close that. There's the form. A picture box, pbox1, timer 1, timer 2. Timer 1 is every 5 milliseconds and timer 2 is every 50 milliseconds. Timer 1, double click it, is purely ball x equals ball x plus speed x, ball y equals ball y plus speed y, draw graphics. The second timer, go back, timer 2 is every 50 milliseconds, and that collision checks for the sides, from the right, from the bottom, from the left and from the top. If it does collide, then bounce it, and also make sure if it shoots off anywhere, just to keep it in the screen and in the box, and then also update the captions, and this is every 50 milliseconds, and by splitting it into 2 timers you get some optimization, so there's less problems for the CPU to keep up. Not that that's much of a problem in these newer computers, but when you start having massive amounts of objects, then it becomes useful to have this sort of demarcation between 5 millisecond timer and a 50 millisecond timer, and then you also have more timers as well, because everything you can stick into a slower timer means less work for the computer to do, and hopefully a smoother graphics. So let's start, and there we have. If you notice, because I put it onto 50 milliseconds for the collision detection, every so often the sides seem a bit spongy and it goes a little bit into the side. So to tighten that up, you can reduce down the second timer So you have properties on the second timer, and you can change that down to say 10. And although this should mean that it's less spongy on the sides, so it doesn't have a time to go further. So that is lesson 3. You're going to have a look at the code for this. So View, Project Explorer, get rid of the properties one. So the code for the form, on the initialize, you load up the sprites, you set speed x equals 4, speed y equals 4, ball x equals 10, ball y equals 10. So this is the starting locations, the starting speed, and load up sprites. If I right click on load up sprites and go definition, this brings up the definition of load up sprites, and this is where you define the back buffer and set up the back buffer, and also load up the background sprite and the ball sprite. So go back to form, view code. Right, I've also got a form key up, and so I've got an escape. If you hit escape, leave, and if you hit Alt F4, leave the program. Very useful. And I've also had to put those two events into picture box. So if you hit the escape or Alt F4 whilst you're over the picture box, you can also get out. If you don't do it in both places, then sometimes the escape key won't work or the Alt F4 won't work. Later on I'll be showing you how to put arrow keys in here, cursor keys, and also using the mouse to control a little spaceship. That's a bit later on. So we've got the key up code. On form terminate, delete sprites, and that gets rid of any memory leaks. Make sure we free up resources, and then you've got the timer 1 code, which is only 3 lines. Move the ball left and right, ball x equals ball x plus speed x, ball y equals ball y plus speed y, and draw graphics. This is timer 2. You've got ball x greater than form1.pbox 1.width minus 32, then bounce speed x equals speed x times minus 1, ball x equals form1.pbox 1.width minus 32. So if it hits the right hand side of the screen, bounce it on the x-axis, and make sure it never goes too far off the screen to the right. And you do the same for the height of the p-box down to the bottom, and then left and at the top. And at the end of timer 2, update the ball x and the ball y. So this is very first steps in using bitblt to create a graphics engine for a game. And you should notice it's a lot smoother than using the standard Windows VB graphics commands, and it's using hardware acceleration from the graphics card. In the next lesson I'll be showing how to do a little bit extra work, and then to use this code to make a direct draw in DirectX 7 command to make even more use of graphics hardware and video cards. And that's that for lesson 3.